And we're live. Yes. Once again, we're back. Oh, what a day. What a world. We're here. I don't know. I got nothing else. Okay. Giving people a few moments to get in there. Good question. I'm going to handle that in regards to the same way that I've typically handled projects. Obviously, if both of your partners want to turn one in, that's between you and the partners. But obviously, this project was supposed to be worked on together. So if your partner turns one in, I have a copy of all of the partners. If your partner turns one in, then the assumption is then, yes, you and the partner worked on that together. So it's going to count for both of you, kind of thing. So obviously, whatever's submitted on Google Classroom is not the same as what's being submitted on Genesis. So, oh gosh. Anyway, where was I? Right, it's Friday. I have seriously completely lost my mind since it's been like 2 full weeks of no kids in the classroom. And next week I don't get to teach again either. So check this out. Today we're going to finish up reviewing whatever we need to review. We've been slowly working in that review over the last several class periods, and today is the last chance we have to review. Like I said, I would be providing for you on Tuesday, because that is the day of your final exam. I would be providing for you the formula sheet that would be needed, or not needed, but that would be helpful in regards to solving these problems. So don't you worry about that. I will provide for you that formula sheet on Tuesday. If you are in my classroom on Tuesday, then you will be taking this exam at your computers. You'll be taking this exam at your computers, knocking that thing out for me within the standard amount of time as I meander through the classroom, and then you will take a picture of said stuff and upload it directly to the Google Classroom, and that would be fantastic. For those of you that would be virtual, which are a lot more people nowadays, but for those who would be virtual, it would be the same thing, except on Tuesday, I don't plan on having a YouTube link on Tuesday. I do plan on having the Google Meet, simply because it's just a lot easier, because I'm not teaching. I'm just going to be, standing and watching you guys take an exam as I meander around the room. So I don't want to put a video like that on YouTube. I'd rather just knock out the Google Meet, and we'll go from there. Today and Tuesday are the last days that I have you. Friday of next week begins the third marking period. Friday of next week begins the third marking period. And not only that, Friday of next week is an A day. I don't know if you have heard that yet, but there you go. There's that information for you. It'd be fantastic. On Tuesday, the 26th, according to this, and you guys should have gotten a copy of this at home. According to this, you'll be with me from 9:28 to 11:40. I guess my intention is this for the final exam. I'm going to give you the appropriate amount of time to kind of get that done. But I foresee there being some extra time before the end of that exam period or something like that. So we'll figure out something to do, I hope that when we're here on Tuesday, I can present said trophies to our fantasy football champions. But again, that depends on what happens next week. I don't know. We'll see. Anywho, as for today, obviously, I want to wrap up the review. You had a project due for me today at 7 a.m. I'm just looking at it right now. And again, of course, the question was asked about, do I have to turn one in if my partner turned one in? And the short answer is no, because your partner, it's a group project. It looks like 7 were turned in out of 21 students. 7 were turned in out of 21 students. Well, actually, no, 7 were turned in, but there were 9 groups. So we'll figure that out, But I'm going to begin grading those, and obviously I should, hopefully by the end of next week, have those done. I just have so much to grade right now. Anyway, what I would like to do, if you do not already have them out, I'm going to need those notebooks out and open to write down whatever we need to write down. But then, of course, I'm also going to provide for you this, and I meant to post this. A class period or two ago, and I kept forgetting to do so. So let me do this now in real time. There we go. I wanted to post the review. Boom. I wanted to post the review to the Google Classroom so that you can see the exact problems that we have been working on. Now, we've done most of these problems already, but obviously I want to finish up the ones that we haven't. So we're going to go ahead and do that. Get my little stuff together here. And my little stuff together here. So for the sake of argument, on the PDF that we have been working on, I would like to start on page 1. Page 1, number 4. So on that PDF, if you're following along, we're just going to go through these one at a time. We're going to see what they have in store for us. I'm going to bring up the chat in my phone real quick. Come on, little thing. There we go. So that if you have any questions, I can see them in real time. They're just loading. There it is. I got you all there. I see all 12 of you. Okay, number 4. A ball is thrown into the air with an upward velocity of 30 feet per second. Nice. Its height in feet after t seconds is given by the following function. In how many seconds does the ball reach its maximum height? And then what is the maximum height? I mean, we've been doing problems like this over and over again, but this is a vertex problem. And again, like I said, a lot of these formulas will be provided for you, but you have to recognize which one needs to be used in which situation. And in this situation, we need to be using the negative b over 2a and plugging in the appropriate numbers. Negative 3 over 2 times negative 16. Please be very careful with how you calculate this. Negative 30 over negative 32. Before I forget, I do already see, obviously, the comments that people have left in the chat. Obviously, if you haven't left a comment, please make sure that you do so. Anywho, I'm going to calculate that. 30 divided by 32. That gives me 0.9375. The ball is thrown into the air, and it takes about a little less than 1 second for it to reach its maximum height. Remember, when you are calculating the vertex, the thing that comes out of negative b over 2a is the x variable, or in this case, the t variable. And then in order to finish that problem off, in order to get that maximum height, you're going to have to take that number and shove it back into the equation in a violent fashion. 0.9375 squared plus 30 times 0.9375 plus 4.5. Let's see what my calculator says. Boom. 18.5625. Now, again, get the appropriate measurement here. They're talking about feet per second in this case. So this is just feet. And that would be an appropriate way of getting that problem done. Excellent. Again, hitting the problems that we haven't finished yet. I'm going to talk about number 6. We also haven't talked about number 6 yet. A golf ball is launched from a tee box on top of a small 8-foot hill with an initial velocity of 120 feet per second. Substitute the values into the vertical motion formula here. Interesting. Hold on, I got to read one thing. Got an email. Another person going virtual. Great. Use the quad formula to find out how long the golf ball will take to hit the ground after it's launched. Again, the quad formula is something that would be provided to you. Keep that in mind, something that would be provided to you. I'm going to plug these information in here. H equals negative 16t squared plus, it says VT, that's the initial velocity, T, plus 8 is the initial height. Interesting. Then it says to use the quad formula. Now, again, with that quad formula, negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a, that formula will be given to you. You don't have to memorize that formula. As I will say here is the formula. Use it appropriately. And you'd be like, oh, thank you, good sir. It would be in your best interest to calculate the discriminant of that thing separately. The b squared minus 4ac, 120 squared minus 4 times negative 16 times 8. It's just in your best interest sometimes to calculate that thing separately, just because it makes life a lot easier. 120 squared minus 4 times negative 16 times 8. Ugh, gross. 14,912. That's gross. Oh well. Now I want to show you, I'm going to actually show you on the computer's graphing calculator in a moment how to get the rest of this thing done, simply because it can be a bit of a chore getting this typed in correctly. Now notice what I just did here. When I wrote out that quad formula, notice what I just did there. I put the quadratic in the appropriate location, or the discriminant in the proper location. Negative b was negative 120, yes. Then on the bottom of the quad formula is supposed to be 2 times a. Now in this case, 2 times a would actually be 2 times negative 16, which I wrote negative 32 to make my life easier. I'll go to my calculator. Going to my calculator on your computer, you need to be very careful with how you're doing this. It would be in your best interest to do something like this to start off. Open up a set of parentheses, negative 120, plus the discriminant that you calculated. Now, again, be careful on your graphing calculators, because when you open up a square root, it has that little arrow key. It has that little arrow blinking right there, which means anything that you type now will be inside that square root. You need to tab over to the right in order to get out of that. Then close the parenthesis. Needs to look like that in order for it to look correct. Divided by negative 32. Be careful with how you type these things in. Now I'm going to show you a trick that I believe I have shown in the past in a moment. So watch very carefully. I get an answer there of negative. That's not how long it takes to hit the ground. Negative 0.07. I mean, it's one of the answers, but it's not the answer. I need to do this calculation again, but this time, instead of going plus, I needed to say minus. I've shown this in the past. I need you to see it again. If you don't feel like retyping all of that, instead, you could click second, enter, and it brings everything back, and you could just tab over to the plus sign to make it a minus sign. The answer is 7.57 seconds. That's how long. Use the quadratic formula to find out how long the golf ball will take to hit the ground after it's launched. Golf balls. Goodness gracious. Some of you know this. I live next to a golf course. I live right on the Ocean Acres golf course. And every year my house is bombarded with golf balls. We've lived there almost 7 years. And in those 7 years, we probably had somewhere in the range of 6,000 to 8,000 golf balls in my backyard. Thankfully, I'm able to sell them 10 cents a ball to the driving range down at West Creek. It's pretty solid, in my opinion, to be able to do something like that. Anywho's it's. Okay. I want to remind you how to do something. I want to get to the right problem for this. There we go. I'm going to, on that PDF review, I am jumping to page 6. Good question. Thankfully, on the side where the balls come in the backyard, there's a giant net, and the net covers the angle of that backyard, and it covers the angle of the house as well. And on the deck that we have, there is also another mini net that kind of protects it, and another separate net that actually protects one of the windows that is facing the direction of the balls coming in. So thankfully, not one window on our house has been broken. I want to repeat that. Thankfully, not one window on our house has been broken. When you have the really bad golfers who miss by well over, I don't even know how many yards, like 50 to 100 yards. They miss 50 to 100 yards to the right, and the ball sails. We have lost a windshield and a driver's side window to direct shots of golf balls because they've cleared the nets, and they've been so far off. Why are you even golfing at that point? Goodness gracious. Anyway, I'm going to jump, like I said, to page 6. Oh, come on, you. Why are you not working? You thing, you. I need a new Elmo camera. This Elmo camera doesn't know what's good for it. Come on, Elmo camera. There we go. See if you work now. No, you don't want to work now? A document camera is not connected. What are you talking about? You're right there. I need a new one. There it is. Now, on page 6, we started doing this problem. About 2 softball players practicing to catch fly balls, and then we ran out of time. So we answered, in fact, let me bring back the page we were working on. This is the page that we were working on right here last time, in which we had to figure out the formula, the quadratic formula, to get that thing done, and then the height of the softball based on the vertex from part C. But now part D and E. Part D. If the teammate misses the ball and it lands on the ground, how long was the ball in the air? Okay. The equation for the height of the ball at any given time, we figured this out last time, would be the following equation. Zoom in on that. Zoom in. There we go. This is part D on page 6. And they want to know how long was the ball in the air for. Well, if the ball is hitting the ground, then the height of that ball is 0. If the ball is hitting the ground, then the height of that ball is 0. So all I got to do is throw that stuff into the quad formula again. Now, I will do that in a moment, and I will knock all of that out, but let me compare that to part E. Let me compare that to part E, because I want you to think about what this thing is. If her teammate catches the ball at a height of 6 feet, how long was the ball in the air? Well, at a height of 6 feet, that's where you would take that equation, and instead of setting it equal to 0, you would set it equal to 6. But in order to solve that problem, you would need to subtract 6 from both sides. Move that up a bit. There we go. You would have to subtract 6 from both sides in order to get it equal to 0. This is using your Algebra 2 skills. So basically, D and E both are quadratic problems using slightly different quadratic equations. Now, what I'm going to do in terms of a little bit of practice for you, I'm going to very quickly figure out what the answers to these two questions are. And then when you are reviewing for this class, you can then take the opportunity and compare how you get those answers to what the actual answers are. So this is practice. I'm going to give you what the answers are to part D and E. I'm going to give you the answers, but then you can challenge yourself to say, okay, can I also get that answer using whatever quadratic formula information I have? So the actual answer to part D is 1.94 seconds. That's the actual answer to part D. And the answer to part E, I have to figure out, boom, okay, The actual answer to part E was 1.75 seconds. And that actually should make sense, the fact that the landing on the ground takes longer than the person catching it 6 feet in the air, because it's just a fraction of a second later. So it's like an extra little fraction of a second for that ball to slam into the ground rather than being caught 6 feet in the air, something along those lines. Okay. So, general conversation right now. What do you need to know for the final exam? You need to know how to enter data into the calculator, run a 1-var stat to get a summary statistic. You need to be able to calculate various statistics, whether it be football, baseball, basketball, whatever, given that the formulas will be given to you. You need to know how to solve quadratics using the quad formula or the vertex, depending on what the question is asking. But again, those formulas will be given to you. You need to know how to properly utilize SOHCAHTOA and triangles in order to answer certain angle problems. Again, the letters SOHCAHTOA would be given to you. I'm going to try and give you as many potential formulas as possible, but again, you have to know how to use these formulas. I cannot show you how to use these formulas during the final exam. You're going to have to know how to convert rates from one unit into another. For example, miles per hour into feet per second. I would tell you that 1 mile contains 5,280 feet. You would have to know how to set up visual diagrams for pictures. Like, for example, I'll bring this one up here. This is one we did the other day with the Phillies pitcher Hoskins the Phillies batter Hoskins versus the Mets pitcher Syndergaard. Determining how long Hoskins had to decide to swing the bat. The dirt formula is something that you would also need. You would have to know, again, how to utilize these formulas, the hang time formula, and the horizontal distance formula. They would be given to you, but you would have to know how to handle them. Making sure that you put your calculator in degrees before you use them. And of course, this formula right here, this vertical height formula, which would also be given to you. As a reminder, those velocities, those initial velocities in those formulas should be feet per second. You're not always given feet per second, so you would have to do conversions to feet per second. And one more thing I just wanted to show you right here. One more thing that I just kind of wanted to do to kind of wrap this up, because I wanted to remind you how to do this. I'm on page 5 of that PDF review. I'm on page 5. And they want you to determine the line of best fit. I just want to review this last part with you. And that should cover all of the information that would be thrown at you on this final exam. Number 5 says to determine the line of best fit for points versus minutes. Now, I know it says to find and explain the R value. I'm not going to harp too much on the R value. I'm really just going to harp on what would be the line of best fit, and you knowing how to do that procedure is a big deal. So let's actually walk through that. On my calculator, I am going to enter in the data for points and minutes. Now, yes, they gave you games. Yay, great. That's not what they asked for. They wanted points versus minutes. Points being the X values, minutes being the Y values. So I'm going to go to my calculator. By the way, somebody answered this question for me. What the heck is going on with the Ball brothers? Are 2 of them in the NBA? And where is the 3rd one? Anyway, I'm just going to leave that there. I'm going to hit Stat, Edit, then I'm going to enter in my data. 1206, 1424, 1316, 1145, 721, 740, 461. Those are the points. I'm going to compare them to the minutes. 3039, 2926, 2866, 2687, 2671, 1797, 1448. Double checking to make sure that my numbers are indeed correct that I need to type in. And I'm going to show you, remind you, how to find the scatter plot of this data and how to have the calculator do the line of best fit. If I want to look at the scatter plot, I'm going to hit second y equals. Oh, I hit alpha. What am I doing? Second y equals. Now it's automatically set to scatter plot, but all of your plots are turned off. So I'm going to turn one on. Hit enter. Turn it on. It's automatically set to scatter plot. You want to see the scatter plot? You're going to have to zoom 9 it. Zoom 9. There's your scatter plot. Points versus minutes. The more points you score, the more minutes you probably played. Or you could reverse them. The more minutes you played, the more points you did. But they wanted points on the x-axis and minutes on the y-axis. So I put points in L1 and minutes in L2. But I'm going to have the calculator do the line of best fit for me. So I'm going to hit stat. I'm going to go over to calc. And I'm going to go down to the fourth option, lin reg. Everything is automatically set. L1, L2, automatically set. You don't have to change anything. Just go down to calculate. My line of best fit, I'm going to write this on my paper, would be y equals 1.46x plus 1028.8. There we go. Now, a couple things in terms of interpreting this. A couple of things. First of all, my slope is 1.46. That's 1.46. Now, change of y over change of x, that's 1.46 minutes per point. Remember, change of y, the minutes were my y values, although minutes probably should have been x, but whatever. The problem wanted that. And I put points at x values. So it basically means that for every additional point you score, there's a predicted 1.46 minutes played. Furthermore, the y-intercept is 1028.8. Now, what that means is, well, if you have 0 points scored, then at a baseline, you would have already played 1,028 minutes. Or, that's the predicted number of minutes you would have played. I mean, obviously, if you have 0 points scored, it's less likely that you're going to score points during a game. Although, I mean, even the silliest of players end up scoring something. But that's what that thing interprets to be. Okay. You have this review. You have the PDF of this review, that is. The past several class periods, in fact, the past 4 class periods, including today, we have reviewed everything that we possibly could on this PDF review. If you have any additional questions, because you could always go back and look at those videos on my school YouTube channel. Like, share, subscribe. But if you have any questions, of course, you can review those videos or you can email me directly. I would rather you email me directly with a single question than not contact me at all with whatever questions you have. Again, as a reminder, I am providing for you a formula sheet. So you don't have to worry about making one up on your own. You just have to know how to use the formulas. That's what it'll come down to. If you haven't turned in that project, please make sure that you do. Like I said, it looked like 7 were submitted, but I know there were 9 groups. But of course, some of those people within the 7 might be duplicates, like partners who decided to both submit it. I don't know. I didn't look at the names. Make sure you get it done. And in the meantime, I will hopefully see most of you on Tuesday for our second exam period, and then that will be the last time that our class will be meeting. Those are tears coming down my face. Make sure you've left the comment in the chat if you haven't already, but otherwise I am going to be signing off at this time. So bye-bye. 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 This is my crab wave. Bye-bye. No one likes it. All right, whatever. I'm out.